Just, of course, a quick review of stuff we just saw, but on something like this, we need common denominators because we're adding the fractions. So I would just take this second denominator 3 and multiply it by the denominator numerator in that first fraction. So this will give me two new fractions, but it should match denominators. 3 times 1 is 3, and then in the denominator, 3 times 7 is 21. And then in the second fraction, I'll take the first denominator, 7, and multiply it into the denominator and numerator. So 2 times 7 is 14. In the numerator, 3 times 7 is 21. Now that the denominators match, well, we can start combining the numerators. So in 20-onths size pieces, we're going to take 3 of those 20-onths and add a 14 of the 20-onths, which when I do in 20-onths, when I add these together, I get 17. And that cannot be simplified, which means that this is our final answer. For 3.1, understanding integers, just knowing what they are. So I know what an opposite, integer, negative, and absolute value are, and I can compare integers, absolute values, and negatives of negatives. Okay, there we go. So on the assignment, you'll see this kind of stuff where it's like, hey, find the opposite of this. So opposite is strictly about negatives and positives. And this is the first time we've seen negatives. On a more academic level, or really just math nerdy level, opposite just means that you're looking at a value that's the same distance from 0, but in the opposite direction. See how nerdy that is? But really all we're doing is changing the sign. All right, so when it asks at the top here, hey, what's the opposite? That's positive 39 because it's not actually showing the sign on it, so it has to be positive. So what is the opposite of 39? Now again, it's not that the number changes itself, but just the sign of the number changes, so it'd just be negative 39. Boom. Yeah, so the opposite of negative 4 is 4. Now this one, it gets kind of tricky. Like, what's the opposite of 0? 0 is neither positive or negative, so technically, in my mind, I think it doesn't really have an opposite, but on the assignment when they ask for it, they just want you to put in 0. Now that doesn't mean you don't type in negative on that because it will mark it wrong if you do that. So be careful. So integers, in the past we looked at whole numbers. So whole numbers would be numbers like it starts with 0, and then 1, and then 2, and then 3, and then this just goes on for just counting numbers like this, but including 0. And these would be considered whole numbers. But if you were to look at integers, then you just go, because this is from 0, I would say going to the right. But integers, instead of going to the right, they go also to the left. So all the whole numbers there are considered integers, but we can go to the left as well, into the negative. So negative 1, negative 2, negative 3, and then again this pattern continues forever to the left. So all these numbers that we see on this list would be considered integers. So the opposite of positives, that's negatives. Right here, we're just looking at the negatives, where in the past, so on a number line, of course, kind of like I showed on that last slide, you can start at 0, but you can go into the positive, 1, 2, 3, 4, 5. And these would be whole numbers, but now we get to go into the negatives, which would be like negative 1, negative 2, negative 3, negative 4, and then negative 5. And this can continue. So in the past, our number lines, they just usually stop right here, but now we're going to be going further to the left of there into the negatives. So when we look at negatives, I don't know. To me, I think money is probably the best option that we have right there, just because we're slightly familiar with money. We've seen it. Hopefully we don't have too much debt, you know what I'm saying, but maybe we have some experience with it. But some people actually understand this better with like elevation or temperature. Like when I was a kid growing up, the temperature thing was a big deal because they had the thermometers. You know, they were filled with that red mercury liquid, and then we'd break them apart and try to stab each other. But in any case, that kind of made sense to me when I was growing up. But generally speaking, at this level, we like to look at money. So down here at the bottom, they're saying, look, if you want money, if you look at money, negative numbers is debt, positive numbers credit, or like getting money, right? Temperature is when you have below 0 degrees, above 0 degrees. So I don't know, maybe Celsius would be better there, maybe not. And then elevation below sea level and then above sea level. So one thing that's missing from this chart though is 0 values. And I really don't know, well, I'm trying to think maybe how that would work for money. But again, if it's neither positive or negative, then it's just 0, which is just like nothing. At least with money, it's like nothing. Temperature, of course, then would be at 0 degrees, whether you're looking at Celsius, Fahrenheit. I think Kelvin's with 0 degrees is too low, but elevation below sea level, above sea level, and then 0 would be at actual sea level. And then reverse, you go up, forward you go down, and then 0 is just staying still. There's probably better ways to say that, but that's what I got. So even though, like, we look at this and we say positive, negative, up, down, credit, debt, whatever. But the 0 part is going to be fairly important in later units. So I like to bring it up now just so we're aware of it. Because sometimes stuff will, it won't move. It will stay still. Maybe you will end up at 0 degrees or sea level. Who knows? So on these problems, it just says express each amount as a positive or negative integer. That's it. We don't need labels for this, which is kind of weird to me. Because when I see word problems like this, my first instinct is to say, I need a label. And then sometimes I still miss it at the end. But the first one, yeah, we got the canyon is 385 feet below sea level. Now, the key word here is below, which indicates that if you were at sea level, you'd be underneath it, which means you'd have a negative value, and then it's just the same value that we have. Boom. Now, again, in my heart, I really badly want to put feet in there, but that's not what it wants. So don't do it on the assignment either. The next one, recorded temperature was 125 degrees Fahrenheit. So positive 125. Now in the past, and we've seen this already, when you put a positive value down, there's no need to put the positive sign in there. Well, I'll say this. If you're doing it by hand, it's okay, right? Like if this was a test and I see that positive sign, that's okay. But if you put the plus sign right there in the assignment, it's probably going to mark it wrong. So I would say just get used to keeping it off so that we understand if it doesn't show a sign, it has to be a positive. We don't always show the positive sign for positive values, but yes, 125 positive. To graph on a number line, find the number and mark it with a dot. That's the first number. When the values aren't shown, you will have to estimate. That's weird. The further to the right, the bigger the value. The further to the left, the smaller the value. So this last statement right here is kind of an important one because sometimes when we compare something like, I don't know, negative 10 with 2, especially when we're getting used to this, students will be like, negative 10 is definitely bigger. Well, it's bigger in overall value, but or in absolute value, but in actual value, it's less. It's kind of like this, and this is where we go back to the money thing. When you say, this was negative, so it's like you owe someone $10. Would you rather owe someone $10 or actually have $2? Well, I hope that you'd rather have $2. I can't say for sure, but for me, I'd rather have $2. And so mathematically, we would say, especially with the number line here, anything to the right is considered bigger than anything to the left. I think we've seen that before, though. I guess we've seen this before, maybe without all this stuff. Maybe it was. But what they're probably going to say is, hey, graph a number. All you got to do is find it on the line and then give us a dot. That's it. So let's place these numbers on this number line below. So I'll do this first one right here. Let's do 9. I'm going to do it in red. So all I do is find 9. Now it's positive, so if I tend to start with 0, where I like to know where 0 is. So I'm kind of extra marking it just so I can tell. It's a positive 9, and since it's positive, it has to be to the right of the 0. And you could count if you'd like, but I can see it right there. Really, it's just scanning these numbers, finding 9. Boom. That's it. All I got to do is put a dot right there. -7, of course, negative, indicates it's to the left of 0. And again, all you got to do is find where that value is. I'll try to color code this. So -7, boom, right there. So put a dot there. And then the last one that we have, 2, right there, it's positive. So it has to be to the right of 0. Found it. That's it. Plot the number that corresponds to the given situation. First, adjust the scale if necessary to allow you to plot the number. Then drag the green slider to the proper location. You lost $75 in the stock market. Change the scale first. Oh, okay. So this is how this is going to work on the assignment. Usually it's going to start with this top number line right here. You'll see it says scale 1. The scale just tells us how much every mark represents. So if I kept it at 1, 1, 2, 3, 4, 5, but you see, even if I make this number bigger or smaller, it's not going to make the line wider or thinner. All it's going to do is change these numbers because that is where the scale is. So if I were to do this, I would click on scale. Now, since I need 75, it's lost 75, by the way. So to go back, this would represent a negative 75. So for the scales, I forget what options they give you. They may give you all the options, all the whole numbers down to 25. But 1, you may have to scroll down to where you get to 25. If you put 5 on here, then each of these would be 5, 10, 15, 20, 25. Again, it's just not big enough. So this may take some playing around with while you're doing this on the assignment. Okay, so you may have to click on it, find the value that you feel works. If you did 20, I think the problem with that is it will not click on middle, like the middle of or in between the marks, which is why like 20 won't work. Yeah, or 10. And I don't know, I guess 15 might work if it was available, but I chose 25 when I did this. And by clicking this and then choosing 25, it changed the scale, right? So now each mark is 25, 50, 75. It's going up by 25 each time. Now that I have that, all I've got to do is find the value that we put on there. It was a loss of $75 right there, so I just got to find it, put a dot there. I believe it's possible you may have to click on this and then drag it over. But if that is the case, do it. If not, then it would just be a click on -75. And that's it. That's all you got to do. If I had chosen something like, I don't know, 20s, right? Then I would have had -20, -40, -60, -80, and then I would have had to kind of guess where -75 is. But by forcing the scale to be 25, it makes the value that I'm looking for, -75, be directly on one of the marks, which I think is pretty nice. All right, so comparing and ordering integers, just like we would with whole numbers. I want to say we've seen this slide before, but it's possible that the line may just not have gone all the way into the negatives here. So yeah, number lines can be helpful because if you can figure out where the numbers are on a number line, just like we saw a couple examples ago, then when it's going to ask us to list these in order from least to greatest, then you just start on the left, you scan this from the left going to the right, and then as you see values, that's when you list them. Of course, they're not going to give them to us in a list from least to greatest. Now, this can be kind of confusing. The more negative, the lower the value. But again, it's just saying the further to the left on the number line, the less it is worth, because you can get into negatives. And if we were to look at this in terms of money, it'd be like owing, right? And just compare this: -1, which means you could owe $1, or -9, you could owe $9. Which one would you rather have? And truthfully, the answer is neither. But sometimes that happens. So. But again, hopefully that's pretty clear. The more negative, the less we want it, so and that's because the lower the value. If it ever compares negatives with positive, negatives are automatically less than positives. So let's just compare these two as they are, right? Now again, if money works for you, just keep it that way. All right, so on the number line, I'm just going to go through this quick then. So on the number line, -9 would be further to the left than -8. That's really all we need to know. and that makes -8 bigger than -9. So this needs to read that -8 is greater than -9. Again, in terms of money, which, use or not use, hopefully you'd rather owe $8 than owe $9, and I'm saying owe because they're both negative. Now, keep in mind, if one of these was negative, one is positive, we don't really care how or what the number looks like. We can compare signs at that point if they're opposite signs. But these ones, same signs, so we need a lower negative for that to happen. If they were positives, and this is a fair enough or a fairly common mistake that we see with students. They see the 8 and the 9 without thinking about the negative, and then they'll put the greater than or less than symbol right there, which is false. Don't make that mistake. All right, let's try this one out. That's it. And all we need to see on this one, the 7, and it doesn't matter that the 52 is a 2-digit number and the 7 is just 1-digit number. The main thing we see is that the 7 is positive and then the 52 is negative, so automatically the 7 has to be bigger. So this would read 7 is greater than -52. But again, it's a common enough mistake for students to put the less than symbol, making it eat the -52, because they just see the 52 and the 7, which is kind of what we've been trained to do. But now we need to train ourselves again to notice the negative as well. Liquid hydrogen evaporates at about -420 degrees Fahrenheit. Liquid nitrogen evaporates at about -298 degrees Fahrenheit. It's pretty low. Which liquid has the lower evaporating temperature? This one right here, since both are negative, the bigger negative would be lower in temperature. So it's liquid hydrogen, which is a lot more writing than I want to do, so copy and paste, bam. So order the values from smallest to largest. I got 6 values, no problem. Oh, well, I thought I was expecting to see more negatives on this. Either way, so when I see these, and you may do it completely different, but for me, when I see these, I like to just identify my negatives, and then I'll identify my positives. So I see right away I've got only one negative. Why am I starting with negatives? Because it says smallest to largest, and negatives are automatically smaller than positives. So I'm going to start by listing the -233. Automatically the smallest number. Now I'll even cross it out just to know that I've used it. But then I'll go to these other numbers. All right, they're all positive. So the next lowest number will be the lowest positive number. So I've got 149, 620, 117, and then 52, and then 160. So there's only one 2-digit number there, which we see is the 52. It does not have any hundreds, but all the other 1, 2, 3, 4 numbers do. So it has to be the next lowest number, 52. Again, I've used it. Let's cross it out. Maybe I forgot to cross them out before, but here we go. All right, that's the only one that has 10s and 1s. Next up, we'll compare the hundreds. Now, the hundreds place value, we've got 100, 100, 100, and then we have a 600. Right there, I can tell that the 620 is the biggest because it has the most hundreds. So I'm kind of set this off to the side in my head and just know that that's going to be our biggest number. But then I need to compare the 100 numbers. So we got 149, 117, and then 160. Now we're going from lowest to biggest, and we see that all of these values have 100. So they have matching hundreds place values, and if we had one that was bigger or smaller, it would be in the list. But they're all the same, so I have to go to the tens place value to get differences in value. In fact, just so we understand what I'm doing, I don't really care about the ones right now. They're there, I just don't care about them. Because if I get tens place values that are bigger, then that's all I really need. So the smallest of those values is going to be the 1. So that came from the 117. And you can kind of cross that out. And cross it out. The next lowest would be the 4 in the tens place value, which comes from 149. 49. So again, we've used it and we've used it. And that means the biggest of those three values would have been 160. So we've used that one, used it. Now I'm at the biggest value, which is the 620. That is all. Negatives of negatives. This is, for some students, this is where math becomes mental abuse to humans, because it's like, what the crap is going on? Negative of a negative? But it's important to remember that, like we saw in the past few slides or so, a negative is kind of just an opposite of a positive. So it's kind of like saying it's the opposite of an opposite. Now we're not saying it's opposite day, because, I mean, you know, that causes problems. But negatives of negatives is when you have a number like, I don't know, 3, but you can have a negative of the negative. So it may look something like this. Sometimes they'll put it in parentheses, but the final value of this is really positive 3. That's it. So the second part is saying it may be helpful to actually change the sign in some of these problems, which means if you see a double negative like this, sometimes I'll see this with students. They'll just kind of make a big plus sign, not only as an operation, but it becomes the sign of that 3 right there. That's a great way to say it. 2 negatives make a positive. I forgot to put them. So you'll see stuff like this. That's negative, parentheses 46. The parentheses are just there almost to throw you off to see if we can do it. But just keep in mind that eventually they're going to do something like this. They'll do like, that's 7 minus 46. But it kind of works the same way, which we'll get to when we need it. But evaluate this. The final value here is the negative of, and that's kind of how this would read, by the way, if it matters. But it's the negative of 46. Or, to put this in terms of what we saw earlier, it's the opposite of 46. And you could put question marks right there, but what's the opposite of 46 or the negative of 46? It's just negative 46. Yeah, that's the answer to both of those, which I guess we should have a question mark there. This one would be, it's kind of like the opposite of, and now we could actually show the negative, the opposite of negative 6. Because the negative 6 is in parentheses, the negative on the outside is just saying, what's the opposite of that? Well, the opposite of negative 6, as far as I know, is positive 6. But keep in mind that that means that value is a positive 6. If I show the positive sign, hopefully that makes sense, because in the future, what they're going to do, they're going to say 1 minus negative 6. Well, that ends up being 1 plus 6 right there, because it's the opposite of negative 6, which makes it positive, and positive means add. So if that were the case, it'd be 7, but we don't have the 1. So once again, some students like to show the work like this with just a big plus sign. Whatever. As long as you get it right, that's what we're aiming for there. So this would be the opposite of the opposite of the opposite of negative 472. I don't like to look at it like that once I see this many negatives. What I like to do, just like we saw in the last one, is just when I see 2 negatives, I can just make it a positive sign. When I see 2 negatives like that, positive. So it's positive of the positive of 472, which, as it turns out, is just 472. That's it. Well, let me try my 2 again. I think that's better. So again, this shouldn't be new, but now instead of it maybe being a positive 17, and there could be a negative 17, whatever. But an absolute value is really just saying how far away is this number from 0. Now, in addition to that, because once we get to the operations, if you have any operating inside the absolute value, it acts like parentheses, so you have to do those operations first. Treat it like a parentheses, solve it, or evaluate it. Once you get one individual value, then you can actually evaluate the full absolute value. So again, when you see these symbols, it's just a question of how far away is that value from 0, which means this one right here is really asking how far is 17 from 0. That's it. So yeah, absolute values are not opposites, because if I were to change this example just a little bit and make this the absolute value of negative 17, like this. Again, it's asking how far away is negative 17 from 0, and that would still equal 17. It's still just 17 away. But it's not an opposite thing. It's how far from 0 thing. Oh, and like we said, I think we said this before when we saw the slide, it's a distance, and distances are not usually referred to in negatives. So, which is why absolute values always come out as positives. Now, just to make sure we understand this, and those are typed in, but those are absolute value symbols, not ones. So this is the absolute value of 76. So the question would ask, or the absolute values are really asking how far away is 76 from 0. It's just 76. I like this example because some students get this mixed up. They say it's an opposite thing. It's not an opposite thing. It's an always positive thing. What is the absolute value of negative 82? Yep, so once again, this would be asking the question, how far away is 82 from, negative 82 from 0? It is 82 away from 0. Distance is always positive. Okay, so this is, and I'll type this one out. Let's do this one. This is negative absolute value of negative 56. It's, I'm going to say that it's the opposite of the absolute value of negative 56. Now, we know that the absolute value of negative 56. So right now, what I'm going to do is I'm just going to focus on the absolute values. Why am I doing that? Because it's order of operations. I have to deal with those absolute values before I can deal with the negative on the outside right there. So it's there. I'm just going to ignore it though. So I start with the absolute value of negative 56, which is asking how far away is negative 56 from 0? It's 56. Now I have to apply the negative on the outside to that value, and I get negative 56. Again, this is kind of an order of operations thing. You have to deal with the absolute value and then anything on the outside, because once again, what they'll do is they'll say, there's 100 right there, and it'd be like minus the absolute value of negative 56. Well, you have to do that absolute value before you do the subtraction. Of course, that's not there yet, but it will be. All right, so the negative of the absolute value of the opposite of negative 1. Now, just by the order of operations, some students, well, I guess there's several different ways to do this. However you do it really is just like those two negatives make a positive. Now, I'm going to rewrite the problem, but without that, the parentheses or the positive. It's the absolute value of 1 right there, but we still have the negative on the outside. Now again, this negative on the outside, let me make it red just so we know where it is. The negative on the outside, I'm not even worried about it, just like the last problem, because I have to do the absolute value first. I have to figure out what that absolute value is first. And the absolute value of 1 is, it's going to be 1, right? Because that would be like, how far is 1 from 0? It's 1 away from 0. But then this negative on the outside is applied to the answer, and we end up with a negative 1 final answer. This one we are comparing the negative absolute value of 6 and also the absolute value of negative 94. Now, depending on how you're looking at this, what we have is we got a couple absolute values on these. Like, let's start with the absolute value of 6. Okay, so how far away is 6 from 0? It's 6. And then again, we got the negative here on the outside, which is going to make that a negative 6. Now, some students, when you get enough practice anyways, this may not be necessary, and you'll understand why maybe here in a second. But the next set, this is the absolute value of the negative 94. Again, two negatives make a positive, so that ends up being positive 94. And it's really how far away is 94 from 0? Well, it's 94 away from 0. And now we can see clearly that 94 is definitely bigger than negative 6. Now, if you knew, like if you looked at this, you may notice that this one has a negative on the outside. This one does not, which means this one was automatically going to come out positive or at least 0. Positives and zeros are all greater than negative 6. So negative 6 is definitely less than 94. Yes, that would be a true statement. And so between the two original statements, we put a less than symbol. So just so we understand, we have the original quantities, but evaluated, this is what we get in actuality. So going back, we would put the less than symbol there. Which of the following statements are true? Select all true statements. Okay, so the absolute value of the opposite of 9 is the same as the opposite of the absolute value of 9. That sounds a little confusing. So let's write it out so we can make some sense of this. The opposite of 9, which would be negative 9. The opposite of 9 is negative 9, but it says it's the same as the opposite of the absolute value of 9. So that would be the absolute value of 9, but the opposite of that, which, when we evaluate, would be negative 9. Yep, that's true. So we get the same value when this second part of the statement is evaluated. All right, the next part, the absolute value of any number is never negative. That is correct. Okay, because if you were to take the absolute value, and then you can put in any number in here. By the way, it could be a decimal, it could be a fraction, it could be negative, it could be positive. That will always come out as a positive something, whatever it is. So yes, this statement is also true. The next statement, the number 0 is the only number whose opposite is the same as itself. Yep. All other opposites. Now, be careful, because some students will say, well, the opposite of 5, its opposite is negative 5, and 5 is the same as negative 5. Well, I mean, they look the same, but they have different signs, so in their overall value is very different. So we definitely would not want to say that that is true. The number 0, yeah, so the number 0 is the only value that works that way, because it's neither positive or negative. This next one, the opposite of a negative number is the same negative number. Let's look at that. So I'm just going to choose any number. I'll choose 20. And it says it's the opposite, so there's a negative, of the opposite of this negative number, which is negative 20. So let's organize this with some parentheses, something like this. Now, just the way this is written, we got these two negatives, which would be a positive. So overall, this would come out as being negative 20. Okay, so that is the same negative number. Yep. The negative 20 is the same as negative 20, which means it wouldn't matter if you use 20. You could use any number there. Yeah, that would be true. This stuff is very, very, very important. So, 0 pairs and integers, okay? Really all it is taking the opposite of something and then adding it to itself. I don't know. For me, it's more of a question on of how do you make 0? But specifically with either addition or subtraction, okay? Now, if you can understand how to make 0, then when we get into solving equations, algebra kind of stuff, then this stuff will come back and hopefully it'll make a little bit more sense. But these are it's pretty much just taking opposites of each other. If you take opposites and combine them, you'll always end up with 0. For example, if I said I had 15 bucks and I was going to combine it with owing 15 bucks like this, well, that means I would be left with no bucks, no money, because the $15 that I have would have to be used to pay off the $15 that I owe, which means my overall net value is 0, or net worth. So they're going to do this with these, they call them tiles like this, and I believe you have to use them on the assignment. So sometimes they'll say, hey, make a value out of these tiles. Sometimes it just is a matter of making 0, what I'm going to call 0 pairs, because if you combine a positive tile with a negative one, another way to say this is that it cancels out. But I worry about canceling out because canceling out actually does have some meaning. And if we can understand that it's really just making a 0, then it's going to help us to go further. Okay, so use chips to represent negative 5 in 2 ways. Okay, well, the first way I would have this negative. So this is way number 1. And we got this negative. There's 2 negatives, so that's a value of 2. And then I got 3, 4, and then a 5th one makes 5. Okay, so this set that I have right here has an overall value of -5, which means that I have one way to show -5, which is the direct method for showing -5. But how am I going to show -5 another way? Well, I know in the end that I have to have an overall value here of -5, like this. Okay, so this also has a value of -5. The problem is that it's just a duplicate of what I did right there. I just copied and pasted that. So it's not a different way. So how do I make -5 stay -5 right there? What I would do is I would end up adding 0. Okay, which means that I would go back up here. Whoops. I would go back up here and, I don't want either. And I would take these two, they're opposites, and then combine them here, like this. Well, these two that I just put in there is going to be 0 pair, like this. As it turns out, if you wanted to, because some students like this, they'll say, look, I'm going to add another set right there. Okay, whatever. Again, you can add as many zeros to -5 as you want, and you'll have a -5 value in the end no matter what. So whether you put 2 0 pairs like this, or more or less, doesn't matter. It's going to end up with the same overall value. They may start with these 7 negatives here at the bottom like this, and they'll say make -5. If I needed to make -5, then I'd have to add these two positives in myself, something like that. Well, that is 3.1 for us, understanding integers. 3.2 will be adding integers, so actually combining the values, and we'll go over that. But